Okay. So the question is previous session. We began this this work of ours probability distribution functions of random variables. Remember last time we defined what a random variable is. So the reason we say that is first 110 times, and the frequency of the face that shows on top, we're calling that one a random variable x, is summarized in the table below. So that is the table. After calculating the mean, you're telling me that your answer is 3.8. You're telling me that your answer is 3.585 something, 3.5 something. Remind me of that answer again.
3.5583.
Okay. So we have just done that. You've just done that using the idea of statistics. Now, what I wanted here, I wanted us to introduce ourselves to the new ways of getting that mean, the variance, the standard deviation, and so on, and the probability theory, using this example here. And I'm going to begin by looking at the mean. Under PDFs, we shall change the name from mean to expectation. In other words, the expected value. But they're all the same. The mean and the expectation, they're all the same. So, under statistics, that is what you do. As that number shows there, that is what you've done. So if, in case the question is under probability distribution, what do we do? We know very well that in the case you have a fair die, whose sides are labeled 1, 2, 3, 4, 5, and 6, that fair die has sides which have equal chances of being on top because it is fair, in other words. So the probability of that x being equal to x, since there are only 6 sides, the chance of each appearing on top is the same. And that is the same as 1 out of 6. All of them, 1 out of 6. Now, you just want to get the mean, or what you call the expectation in this case. We can simply get that using the x times the probability of that value of x and the sum of all of them. I am calling the expectation summarized as is simply equal to the summation negative infinity from the smallest value up to the biggest value of x. X equals to summation of probabilities. So which means that in case I'm to multiply this x times its probability. X. So here I will simply get 1 out of 6. Then 2 times this, I'll get 2. I'm going to reduce. I'll reduce later on. The same applies here. Multiply these 2, you get 3 out of 6. And then 6 out of 6. Then in case I'm to get the mean, I'll simply add up all of those, which will give me the answer as 1 out of 6 plus 2 out of 6 plus 3 out of 6 plus 4 out of 6 plus 5 out of 6 plus 6 out of 6. And from the calculator, you can see, or can simply add that this is 6, 10, 15, it's the same as 21 out of 6. And on the calculator, that is the same as 3.5. that is what I get. That is what I get. Hope that you also use the calculator and you've got that same answer. Meaning that
Yes.
we can get the mean. We can get the mean when you round off your answer to one decimal place. That is what you get. So meaning that we can get the mean. We are calling the expectation or the under probability theorem simply by using this expression here. So what you can do, you can also copy this. You can also copy this. So in short, the mean or the expectation of the random variable x, that is in probability theorem, is given by the e of x, expectation of x, as the summation from the smallest value of x, that is x negative infinity, to the highest value of x, which is positive infinity, into x times the probability of that value of x. This is x. This is x here, not r. This is x. Like that. So, after having looked at this, let's have a quick or a short example here. Then I explain something else. Let me first write it down. Okay, so that's our question for this. So the question says that given that variable capital X has a probability function or a probability distribution function given by the given f of x, so that f of x is the same as the probability of x, and that has been given in this box here. That is our function. Squared is the constant, and the saying that x is between 0 and 4. After having this, then the question says that determine the value of the constant c, determine the probability of x equals to is greater or equal to 1, and then find the expectation of x. So what I need you to do is you try to find the value of the constant c, then I begin from there. Or even part B, you can try it out. First try it out, then I discuss your answer as well after trying it out. Okay. So the part A, you got it correct. It is 1 out of 30. Part B, you're saying that you got 1. Let us try it out together.
Okay.
It as well, but let's do it together here and we see. So we have been given that we have a function given by the function being equal to cy squared for 0 less than or equal to x less than or equal to 4. So meaning that we have our value of the small value of x, here we have the probability of x equals to x, and the values of x are ranging from 0, this is 0, 1, 2, 3, and 4. So when it comes to filling up this space here, we must use our equation, which is this. So we substitute in for the value of of x. I made a mistake here. This is supposed to be x. This is supposed to be x. You can correct it too. Cx squared like that. You correct it. So where there is x, we put it there. Are these values of x here? So to start with 0, c times 0 squared, that gives us 0. C times 1 squared, that gives us c. C times 2 squared, that gives us 4c. C times 3 squared, that gives us 9c. And c times 4 squared, that gives us 16c. And the rule says that when you get the sum of all these, you must get a 1. Now let me try out this one on the next page because I need to fill up this other space down here, as I'll show you later on. So the next page, you can say that summation of all x, probability of x equals to x is equal to 1. So we shall have 0 plus c plus 4c plus 9C plus 16C gives us a 1, which implies that when we add up all of those, it will give us 30C. 16 plus 9, that is 25, 29, 30C, yes, equals to 1, implying that our C is equal to 1 out of 30, which you have got, and that answer is correct. Then part B says that find the probability of x greater than or equal to 1. And we say that this is the same as probability of x equals to 1. 1 is inclusive, so begin from 1. Plus probability of x equals to 2 plus probability of x equals to 3 plus the probability of x equals to 4. We say that when you're getting the probabilities, first of all, leave your C in that expression. Only substitute on the final stage, because in case you fail the value of C, at least in this question, you get some marks, the method, and so on. So for 1, we had a C plus 4C from the table, plus 9C plus 16C, which will give us 30C, like that, which is therefore the same as, so this is why you substitute on the final stage, 30 times 1 out of 30, which gives us a 1. And that is very good. You got that answer correct. But I wanted to share with you the alternative method. Alternatively, you can say, like what we discussed before, that the probability of x greater than or equal to 1 is simply the same as the sum of all the probabilities, which is 1, minus the probability of the values of x which are less than 1. Because in this one, we have greater than or equal to 1, meaning that the 1 is inclusive. So in writing the less than or equal to, you don't include that 1 in that expression. So this is the same as, write down here, this is the same as 1 minus the probability of x equals to 0. And from what we have in the table, it is the same as 1 minus 0, which gives us a 1. So you can always look at the shorter way of getting the answer, but all the values are correct. Then part C was saying that determine the expected value, determine the expectation of x, determine the expectation of x. And by definition, I would say that this is the same as the summation of all x times the probability of x being equal to that value of x. That is the definition. And this is the same as, so you substitute the values. But you always summarize everything in the table, meaning that we shall go back to our table and we simply write that x times its probability down here. So we shall say that the summation of x at p of x equals to x equals to x, we shall add the total here. So this is the same as, we can add here, so you multiply the x with its probability. So here we have 0, x times its probability. Here we have c, x times its probability. Here we have 8c, x times its probability. 3 times 9, that is 27c. Then x times its probability. You get 4 times 16, that is 32, 65. Okay? Yes, you're saying something?
Yes, yeah, I was saying that, teacher.
Okay, okay. So when you add up all of them, what do you get? Calculate.
100.
You get 100. 100C.
Yes.
Let me verify here. 1 plus 8 plus 20 plus 24. Yes, you get 100C. Our expected value is equal to 100C. So let's as 100 was 1 out of 30, which gives us 0 cancels here. We give yes, 3 recurring, 3 recurring. So that is our answer. Now, in the same way, I just want to do a simple exercise here, and you find for me the expectation of 2. The 2 is a constant. The expectation of 2x, the expectation of maybe 2x plus 4 plus 2. Okay, let me just add 2 here, just to bring my point home, like that. So I need to get for me these answers here, the expectation of this, expectation of this, expectation of this. What you do is very simple. If you have got, let me write it on the new page here. Let me first rub off some. I've rubbed off something that I wanted. Okay. So you're going to find the x, in case you're going to get the expectation of x, we say that this is the same as you multiply the x with its probability. And if you go to the 100c. Likewise, in case you're going to get the expectation of any constant a, let me just use the a, ig, expectation of 2, you're going to simply have that a times the probability of x equals to x. So multiply that a with the probability of all the values of x, you get the answer there. Likewise, this is the same as probability of, likewise, when you get the expectation of, for example, 2x, this is the same as if I use instead of the 2, I use ax. Let me just use a here. This is the same as ax times the probability of x equals to x. Summation. Everything there's summation there. Like that. So in other words, on our table, I have rubbed it off by mistake. We had values of x, then probability of x equals to x. 0, 1, 2, 3, 4, 5. No, we're stopping at 4. So here it is 0, 1c, I think it was only c. Then 4c, 9c, 16c, like that. Summation of all the probabilities of x equals to x equals to 1. So where we have the mean, I say that you simply multiply the x times the probability of x equals to x. And all of these ones we've got a summation of x into probability of x equals to x. We've got this as 100c, which we have finished. So the other definition of getting the expectation of a constant, which we had as 2, we're going to get 2 times the probability of x equals to x. For example, here we can have 0 times 2. You get 0. Then c times 2. You get 2c. Then c 2 times 4c. You get 8c. I'm just throwing out this one for you. I'll give you the final answer. Yeah? I mean, you'll get me the final answer. Okay, let me just complete it to bring my point home. So likewise, 2, a constant 2 times 9c, I'll get 18c. And then 2 times 16c, I'll get 32c. So when you multiply all of those, summation of 2, probability of x equals to x. Tell me here, what do I get?
Shall you get 60?
You get 60.
Yes.
Okay. 60C. Meaning that our answer for this one here for x, which is equal to 2, here the answer will be equal to 60C, which times 1 out of 30, which will give us
2.
Will give us the answer as being 2. I need to take note of this. I need to pay attention to this and the answer to that you have got. We shall come back. But if I copy that,
I'm done.
Okay, that is good. You're done. That is good. So then the other part was expectation of 2x. So we try that one as well. In our table, we have expectation of 2x. Let me first rub off this because I don't need it. Let me rub off this. But for you, you can just write down below.
Okay.
You cannot be like just continue down. So you have 2x times the probability of equals to x. So here we have 2x times the probability of 0. The answer is 0. Then we multiply 2x, that is 2 times 1 times the probability, which is c. So we'll get 2c. Then we multiply, let me change the color. You multiply 2x, that is 2 times 2, then times the probability, which is 4c. 2 times 4, 4 times 4, that is 16. Okay, I'll get 16. Then 2 times 2x, 2 times x, which is 6, then times 9c. 6 times 9.
Pardon?
We are multiplying 2x, which is 2 times 3. 2 times 3, then times its probability. I'll get 2 times 3, that is 6. 6 times 9, that is 54. Then 2x, the x now is 4. So 2 times 4, that is 8. Then 8 times 16.
120.
128c. Like that. So the summation of probability of x equals to x
200.
will be equal to 400. Correct. 400c, meaning that our answer will be equal to 400c, which is the same as 400 of 30. This will give us 40 out of 30. 40 out of 3. To give us 40 out of 3.
Can I have 200?
You have?
200C.
Hold on, what did you tell me? Hey, you told me 200. You told me 400. Sorry.
I was
Supposed to be.
yeah 200.
Okay. So 200. Okay. So when I change here, I'll have. Sorry. I'll have 200C. I change this to 200. So I'll have 20 out of 3. And when you get a calculator, 20 divided by 3 is the same as 6.6667 and so on. Now, still here, what I need to note is that our mean was, it is even here. This was our mean expectation of x. Now, when you have a constant e, a constant times the value of x is the same as getting the constant a in two brackets expectation, expectation of x, yes. So in this question, like for example here, when you compare this with this, the a is equal to 2. So 2 times 10 out of 3, you get 20 out of 3. Okay, the last part that I want us to look at, then I give you the general rule. The general rule. We're getting the expectation of 2x plus 2. Of course, in the table, you're going to come to the table here, and you get, which one should I rub off? Let me rub off that one which you have just done. Or let me rub off this one down here. So we have to get 2x plus 2 times the probability of x equals to x. Now I want you to try out this and get me the values here. Get me the values here, and then get the total when you have substituted there. Let me you try out that, then tell me the answer, and then you go to our conclusion. I beg your pardon, what answer have you got?
The final answer I got is 8.6 recurring.
8.6 recurring. Which was, remind me before this?
260.
260.
C.
Okay. So, now we're going to compare this answer with the general rule. We can simply have this as the generally, in short, in summary, compare all those answers that you got. In summary, the expectation of the constant is 1. The expectation of the constant is equal to the constant. Then number 2, the expectation of a constant times x will give, and then the variable, and the expectation of x like that. That is another rule. And then finally, number 3, the expectation of a function ax plus b, where a and b are constant. It is the same as, when you open, the same as a expectation of x plus another constant b, like that. Where a and b where a and b are constants. Where a and b are constants. Now, because of time, let me also go to the variance, and I simply comment about it as well. The variance, remember we looked at it in statistics as well. I don't want to go to the what we did for the expectation because of time. So the variance of x, and the standard deviation, and you can simply say that to recall in statistics, the variance of x was given by summation of f of x squared over summation of f minus the mean squared. And the standard deviation was simply equal to the square root of the variance of x. This was in statistics. How about in probability theorem? What do we do? Let me go to the next page here. So we shall say in probability density function is, in the probability distribution function is, our variance of x will simply be equal to expectation of x squared minus expectation of x, but you square. In other words, it is the mean squared. Expectation of x squared minus the mean squared. And the general rules, or before I go to the general rules, I can simply add on this that note that standard deviation is the square root of the variance. And then you can say that the general rules for variance of x are, I want to go to the next page. If I give you time to copy that.
I'm done.
So rules are, number one, when you have variance of a constant that is the same as 0, it is simply equal to 0. If they say that find the value of the variance of 2, the variance of 8, the variance of 100, that is simply equal to 0 straight away. And then the variance of the variance of a constant, number 2, the variance of a constant times x. This is the same as s squared times the variance of x. When I give the examples, you can try them out, and then you do them manual, and then you see what you'll get. Implying that you have variance of ax plus b. This is now like a function. Open the bracket. This is the same as a squared variance of x, then plus 0. Plus 0. Let's have examples here and we see what we are talking about here. So let's have one example.
Okay.
Again, examples. Example 2. You can say, let me first stop the recording, then I plug in. Now we can be given a question like that, given that a PDF, the probability density function, the probability distribution function of a discrete random variable x in the table below. They've not given us a function this time around, but that function has been given to us in form of a table. They've already done that one for us. Now, before you do anything in such numbers, before you do anything, make sure that you test that you have the correct work by getting the summation of all the probabilities. They must be equal to 1. If they're not equal to 1, then it means that the question has a problem. There's something that is missing out. So you get a calculator and try out adding all of these and see whether you get to 1. If you don't get to 1, then there is a mistake in our question. For example, we can have 0.2 plus 0.2 plus 0.2 plus 0.3 plus 0.1. The answer is 1. So meaning that we are good to go. Otherwise, in case it is not equal to 1, then just know that there's something wrong. Now, what I wanted us to do is to get the variance, the expectation, the standard deviation, and so on. But let me change the question a little bit, and I put here a K. Let me put here a K, and I alter my question a little bit. So I will say that determine the part A value of K. That is 1. Then Roman 2, or part B, find the expectation of x. Part C, expectation of x squared. Part D, the expectation of 4x. And then I'll say that find the variance of x. And then part F, I'll say that find the variance of 2x. Yes, those are my questions for you to try out, but we're going to try them out together. Then I'll give you another question for you to try out, which you will answer and send the work for marking. So to start on this, we have values of x and their probabilities. Values of x and their probabilities 1, 2, 3 up to 5.2, k, and so on. So I'll say that solution, we have values of x, then probability of x equals to x. I'll have 1, 2, 3, 4, and 5. I can simply write here sum. This is like this. Let me draw long ones. So I had 0.1, sorry, was it 0.1? Let me check.
Zero point two.
0.2. 0.2, 0, and then 0.1. The sum must be equal to 1. Now, before you waste time in the space of doing everything, just know this as part of the solution, that this one is given by the summation of x, okay, x equals to x. So that this one is given by x squared, probability of x equals to x. This is what we need in the table, in other words. This is what we need in the table. Then this one here, the rules that you have just said, 4 times the expectation of x, which really got it above there. Then this one here, as expectation minus the expectation of x, that here, just like we did in statistics. And then this one here, it is the same as. So for this one here, we don't need to calculate anything else in the table because we have there as well. And then for this one, from the rule, the same as 2 squared times the value of x. That is never in the table. Only need two more rows. These are the ones. So let's begin. In the table, we shall have probability of x equals to x by getting the value of k, and then squared of probability of x equals to x. So we can start now. This times this we get 0.2. Okay. Here we get a 0.2 and then 0.5. I hope I'm correct there. You correct me in case I'm wrong. You can work out as well. You can be copying as well. So 1.2 plus 0.5 plus 0.6, 0.2, that's 2.5. plus, okay. That is for the expectation. Then for expectation x squared, 1 squared times the probability shall have 2 squared times the probability. Okay. 3 squared times the probability. We'll have 9 times 0.2, that is 0.2, give us 1.8. X squared times the probability, that is 4 squared, that is 16. And the probability, which is 0.3, which is 4.8. Then 5 squared times the probability. 5 times 0.1, that is 2.5.
5.
And then the summation will be 2.5, 0.8 plus 0.8 plus 2, 9.3, then plus, and that is what you need. So after you've done, you can go and answer our question. That A, value of k summation of probability of equals to x, all will give us 1. Means that add 2.5 plus 2k. 2.5 plus 2k. 2.5 implying that 5 plus 2k equals 1, which means our k equals to 1 divided by, you can just get the answer straight out. 0.2. Straight out. 1 is that correct?
Yes.
1 minus 2.5. I'm getting a negative. There's something wrong.
But teacher,
There's something wrong.
how about you use the very first row?
Hey, I made a mistake. The mistake is here. The mistake is here. Okay, that is correct. What I told you is correct. The summation of this, we don't do this. Or this. Is that correct? That is wrong. That is wrong. So use the first row for opportunities. We shall say that, let me go back. When you add up all these, what do you get?
0.8.
0.8 plus k, correct. So 0.8 plus k equals to that out of 0.2, correct.
Yes.
We're leading to something else. So part B, the expectation of x, summation of all x, of x beta, x equals to x is the same as 2.5 plus k. I think it was like that. Let me check again to close.
Yes.
Expectation of x is here. 2.5 plus 2k. Correct. So when you substitute for the value of k, the same as 0.5 plus 2 is 0.2. What answer do we get?
2.5 plus 0.4, which is equal to 2.9.
2.9, correct. Then part expectation of x is the summation of all x, x squared bit equals to which gives us, it gave us 9.3
3.3 plus 4k.
It was 9.3 plus 4k. Is the same as 9.3 plus 4 times 0. What does it give us?
10.1.
10.1, correct. 10.1, correct. So once you have got those, then the others become very simple using our. Yeah, yes, okay. Part D was saying that find the expectation of what?
4x.
It's the same as 4 times the expectation of x, which is expectation of x. We've got it as 0.9. And we get the answer as 2 times 4 times
11.6.
Correct. Then part E, variance of, which is the same as expectation of minus expectation of x, that is expectation of x, we got it as 10.1.
Yes.
1 then minus expectation of x, we got as 2.9.
Yes.
2.9. So get 2.9 squared.
Which is 8.4.
8.4.
41, yeah, 8.41.
So the final answer will be 1.9.
0.69.
Then part of the standard deviation, I think, I don't know that part of the variance of x, you can compute that. D, a variance of 2, the same as 2 squared, the same as 4 times 1.69. 6.79. 76.
Yes.
So that is what we do. What we do. In case you want to do it manually, the first example, okay with you. In case you want to do the rules are simple and they're shorter. So that is what we do. I'm going to stop here now. I'll start from there next time. Next time, when relative distribution function, relative distribution function for the, as well as how to get the mode, how to get the median, and so on. So it's like we're repeating ourselves of what we did under statistics. I'm stopping there for now. See you next time.